Now we're gonna look at the beta imino carboxylic acid heating. So we have R C double bond O C double bond NH CH2 C double bond O OH that we heat. So similarly, we have seen beta keto carboxylic acid. It is also alpha beta imino carboxylic acid. On beta there is imino R C double bond O NH CH3. Then CO2 gas will be released. Now look at its mechanism. We have amino R C double bond NH. Then we have CH2 and C double bond OH. This is a 6-membered cyclic transition state. When we heat this, we form R C double bond NH. This hydrogen attached over here, and it forms CH2 negative. It forms CH2 negative and CO2 gas will be released minus CO2. Now this CH2 and this NH plus. So this NH plus, the hydrogen will get transfer over here. So it forms R C double bond NH and CH3. It will form imine. So that's how this CO2 gas will release. The CO2 will be removed and remaining part will retain. So let's solve some problems regarding to this equation. First is we have NH COOH. When we heat it, it will form NH plus CO2. Second, this is double bond NH. When we heat it COOH and the double bond NH, imine COOH, it is beta position with respect to carboxylic acid. So when we heat, we know due to cyclic transition state, for this form 6-membered cyclic transition state, and this type of compound it will form. Third, we have NH and C double bond OH. When we heat it, it will form double bond NH. Fourth, this type of compound do we have? We have double bond NH and COOH. The beta position, again all compounds have similar type of problem. We have COOH, acid over attached over here. Let's look at the fifth problem. We have double bond NH and COOH. It is beta position with respect to carboxylic acid, so it will form double bond NH and this will form. Sixth, we have C double bond OH, C double bond O CH3, hydrogen and CH3. When we heat it, it is beta keto carboxylic acid and C double bond O NH. It is actually NH, beta imino carboxylic acid. So it will form DH, C double bond NH and CH3 and CH3. This question represents that there is no change in the configuration of alkyl group. Configuration is retained. Now let's look one more problem regarding to the retention and some more good examples like CH3, CH2, C. It is a Fisher projection. C double bond OH, C double bond NH, CH3. Then here we have CH3. When we heat it, it will form C2H5 hydrogen and C double bond NH and CH3 and CH3. It is retention. The configuration is retained because it is beta position. Alpha beta position with respect to carboxylic acid. Then it is retention in configuration. eighth NH, COOH, COOH, NH. When we heat it, it will form NH, NH2 plus 2 CO2. It will form plus 2 CO2. Because again, every question we have beta position respect to the carboxylic acid. Then we have COOH, then double bond NH. When we heat it, both the carboxylic acid will go and the remaining compound. Now it will form tautomer and it will form a benzene ring, aromatic compound. 10th, the last but not least, we have COOH and double bond NH. We COOH, we have this compound. So every time we have a beta position with respect to carboxylic acid, a compound like alpha beta, alpha beta, alpha beta. Here we have alpha beta. All four COOH will go, and after tautomer, all four COOH will go, and the remaining compound are, there is a double bond NH, double bond O, double bond NH, double bond O, which will form a tautomer to the NH2 OH, NH2 OH. This will form a compound.